An ordinary day. You wake up, feel the warmth of the sun's rays on your face, look out the window at a bright, light-filled world. The sun is such a familiar part of our lives that we barely give it a second thought. It's just there. But now, imagine it's gone. Just clicked off like a switch and went out. What would happen next? Would instant darkness and chilling cold descend? Would we all freeze to death overnight? The answer is far more complex and fascinating than you might think. And this journey into a hypothetical doomsday will begin right now. The first thing to understand, and this is perhaps the most astonishing fact, is that we won't know about it immediately. Nothing will happen, not for the first second, nor for the first minute. For an entire 8 minutes and 20 seconds, Earth will continue its journey in orbit around empty space. We will see the sun in the sky, feel its warmth, and everything will look absolutely normal. Why? Because light and gravity are not magic. They don't work instantaneously. They need time to cover the immense distance of 150 million kilometers that separates us from our star. The speed of light, as we know, is finite, and gravity, as Einstein predicted, travels at the same speed. So, humanity will have a little over 8 minutes of complete unawareness. 8 minutes to finish their morning coffee, drive to work, or simply look up at the sky, utterly unaware that the source of that light no longer exists. But then, the countdown ends. 8 minutes and 20 seconds have passed, and at this very moment, two things will happen at once. The first will be visual. The sun in the sky will simply vanish. It won't set, it won't dim, it will simply vanish. As if someone had cut it out from the canvas of the sky. The world will be plunged into an absolute, impenetrable darkness, a darkness unimaginable under normal circumstances. This won't be just any night. This will be a night without a moon, because the moon doesn't shine on its own, but only reflects the sun's light. It, too, will become invisible. The sky will transform into a velvet black dome, strewn with incredibly bright, non-twinkling stars and planets. Venus and Jupiter will shine like powerful spotlights. The Milky Way will appear in all its glory. The sight will be truly majestic and terrifying. The second event, occurring at that same instant, will be gravitational. Earth, no longer held by the sun's gravity, will tear away from its familiar orbit. It will cease to orbit the center of the solar system and will fly in a straight line, like a stone flung from a slingshot. Our planet will become a rogue planet, wandering through interstellar space at a speed of about 30 kilometers per second. Of course, initially, we won't even feel it. No jolts, no shaking. We will simply hurtle into the endless cosmic void. But darkness and the break from orbit, these are only the first and perhaps not the most terrifying problems. The main enemy was already closing in on us, the universal cold. Without the sun's warmth, the Earth would begin to cool rapidly. But then again, not instantly. Our planet has two enormous heat reservoirs, the atmosphere and, more crucially, its oceans. In the first few hours, the temperature drop would be noticeable, but not catastrophic. The planet's average temperature would plunge to 0 degrees Celsius in about 1 week. After 1 month, the world would already resemble Antarctica, with an average temperature of around -20 degrees. And after 1 year, the Earth's surface would freeze down to -100 degrees. That's colder than anywhere on our planet today. What will become of life? Plants will be the first to perish. Photosynthesis, the process that underpins nearly all life on Earth, will cease the very moment the light goes out. Most small plants will perish within a few days or weeks. Larger trees will be able to survive longer, for a few years, sustained by their internal reserves, but their fate is also sealed. This will collapse the entire food chain. Herbivores will begin to starve, and predators will follow suit. Humanity, of course, will find itself in a more advantageous position. We have food stockpiles, technology, but how long will they last? Electricity will be gone fairly quickly. Hydroelectric power stations will grind to a halt once rivers freeze. Wind turbines will become useless in the frozen still air. Solar panels, obviously, will turn into pointless pieces of silicon the very first second. Only thermal and nuclear power plants will remain, but even they require fuel, and extracting it amidst perpetual night and brutal frost will become a virtually impossible task. Cities will plunge into darkness, and bonfires and makeshift stoves will become the only sources of light and warmth. A struggle for resources will begin: food, fuel, warm shelters. Society as we know it will collapse in a matter of months. But does this mean that all life on Earth is doomed? Not quite. And this is where things get really interesting. The oceans covering most of our planet will become life's final arc. Water possesses enormous heat capacity, which means it cools down extremely slowly. Within the first year, the surface of the oceans will be covered by a thick layer of ice. And this icy shell, tens and then hundreds of meters thick, will play a crucial role. It will become a gigantic insulator, protecting the watery depths from the cold of space. Beneath this icy crust, in complete darkness, liquid water could exist for hundreds of thousands, and perhaps even millions of years more. Of course, life dependent on photosynthesis will disappear there. However, deep in the ocean, by geothermal vents, the so-called black smokers, there exists an entire ecosystem that doesn't need sunlight at all. The bacteria living there obtain their energy not from the sun, but from chemical reactions utilizing hydrogen sulfide gushing from Earth's depths. This process is called chemosynthesis. These bacteria serve as food for other organisms: tube worms, shrimp, and crabs. This deep ocean life wouldn't even notice that the sun has gone out. For them, nothing would change. Therefore, life on Earth wouldn't vanish completely. It would simply go underground, or more accurately, beneath the ice, reverting to its most primitive forms, patiently awaiting billions of years until our wandering planet is perhaps captured by the gravity of another star. But what about humans? Do we have a chance? Theoretically, yes, but it's very small. Humanity's survival will depend on how quickly we can adapt. The only source of energy capable of sustaining civilization under such conditions would be geothermal heat and nuclear energy. We would have to build underground or underwater cities near geothermal sources, for example, in Iceland or in the vicinity of mid-ocean ridges. These would be completely sealed, autonomous shelters. In these ark cities, we would have to recreate the ecosystem, growing food hydroponically under the light of powerful electric lamps, drawing energy from the heat of the Earth's depths, raising animals, recycling absolutely all waste, creating a closed loop. This would require an incredible level of technology, organization, and most importantly, the unity of all survivors. Small groups of people might be able to survive in this manner for many generations, becoming an underground civilization. They would tell their children legends of a distant past when overhead there wasn't a kilometers-thick layer of ice, but a vast, warm sun in a blue sky. They would never see the stars, but they would remember them. Meanwhile, Earth would continue its icy journey through space. Over time, the atmosphere would freeze and fall to the surface as liquid nitrogen and oxygen snow. The planet would transform into a smooth, icy sphere, hurtling through the darkness. What would its ultimate destiny be? Perhaps after millions of years of wandering, it would be captured by the gravitational field of another star and find a new home. or it would be torn apart by the gravity of a gas giant. Or it would wander eternally through the void, like a silent monument to a world that once thrived. But let's take a breath. All of this is just a grand thought experiment. Our sun isn't going anywhere, at least not in the foreseeable future. It's a stable star, a yellow dwarf, and it has about 5 billion years of fuel left. That's more than the Earth itself has been around. So we still have time. Of course, in 5 billion years, the sun will start to swell, turning into a red giant. It will engulf Mercury and Venus, and most likely incinerate Earth. But that's a whole other story, and by then, humanity will either find a way to relocate to other stars, or it will have vanished for some other, more prosaic reasons. This scenario, grim as it may be, perfectly demonstrates just how dependent we are on that enormous fiery sphere in the sky. We take it for granted, complaining about days that are too hot or too cloudy. But every photon of light, every joule of warmth, it's a gift that makes possible the existence of everything we know and love. From the morning bird song to the most complex technologies, all of it runs on the sun's energy. So next time you feel the warm sun rays on your skin, just pause for a second and realize what an incredibly fortunate and fragile world we live in. A world that exists only thanks to a distant and eternal star named the sun.